Hi, welcome to chapter 1. Right, this is the third lesson. Right, you'll be on the addition of algebraic fraction. Alright, so for this lesson, we're going to cover on how to do the addition of algebraic fraction. Now, before that, just want to have a recap with everyone on the knowledge that we have learned in primary school. Alright, so let's start off with a simple question. Half plus 1/3. So let's recall how do we do this without the use of calculator. Right, so I'm sure of you will have some memory. Okay, what we do is we multiply like the denominator of the other fraction, okay, to the numerator as well as the denominator. Right, so the first fraction, numerator denominator multiplied by 3. Second fraction, numerator and denominator multiplied by 2. Okay, so first fraction will change, becomes 3/6. Second fraction becomes 2/6. Now this process is called common denominator. Right, so this is a common denominator. After which, because the denominator is the same, we can then combine them into a single fraction. Right, so over here you see the denominator, we don't go and take 6 plus 6 and gives me 12, right? Right, so the denominator is the same, right? The sign here, the plus sign, is actually for the numerator, 3 plus 2. Okay, and then we end off with the answer 5/6. Now, so for this part here with algebra, basically the scale is exactly the same. Okay, how? So now if I have a question like this, okay, if I have a question like this, right, 5/2x plus 4/x plus 3. Now, if I take reference to these two, okay, you can see that this fraction is basically like half. Right, this fraction is basically like 1/3. Okay, of course it's more complex because of the x. Then first step, what do we do just now? Right, I'm multiplying by the denominator of the other fraction, right? So the first fraction half, I times 3 times 3. Why? Because the denominator of the other fraction is a 3. So now if I look right here, the denominator of the other fraction is x plus 3, right? Now, if the denominator has more than is 2 terms or more, right? First thing, bracket them, group them together, right? Then I'm going to employ the same method, meaning the numerator and the denominator, I am going to multiply by the same, x plus 3, top and bottom. Why? Because the denominator is x plus 3. Then what do I do with the other fraction? Well, I multiply by 2x, the denominator. So top and bottom times 2x times 2x. Now the working here, of course, is pretty messy. For you, you don't have to write the working. Okay, you can straight away write this. Right, so you can see the numerator multiplied by x plus 3. Right, the denominator also multiplied by x plus 3. For the second fraction, numerator multiplied by 2x, the denominator multiplied by 2x. Just take note the x plus 3 needs to have the bracket. Right, so is it top and bottom multiplied by the same value for each fraction. Right, exactly the same scale. Of course, it looks complex, but the scale is the same, right? Then after that, what do? I combine to a single fraction, right? The denominator remains the same. The sign goes to the numerator. So what I'm going to do is combine them. See, numerator 5 bracket x plus 3 plus 4 bracket 2x, exactly the same. Okay, so this part here forms the numerator. The denominator, don't go and multiply by 2 or add them together. They are the same. Okay, just like here. Just like what we do in primary school. Okay, once you combine them into a single fraction, the denominator, there is no need to expand. Okay, don't expand the denominator. Okay, keep it factorized. There is no need to expand. Okay, then what is this step? What am I doing? Okay, just like the 3 plus 2, I evaluate to 5, right? I simplify it to 5. So I simplify the numerator. So I only expand and simplify the numerator. So expand it, okay, I'll get 5x plus 15 and plus 8x. Then Like terms add together, 13x plus 15 over 2x bracket x plus 3. This will be the answer. There is no need to expand the denominator. Alright, so after you understood this, okay, you can watch the next video on how do we then do subtraction of algebraic fractions.